Okay, guys, so this is the review for the complex numbers and rational exponents quiz. This is the last part of unit 3, and then we get to move on to unit 4. Okay, so for question number 1, how many real solutions does x squared plus 10x plus 20 equals 0 have? And show your work. So I know some of you might think right away, well, I see a squared, so I'm going to square root both sides, and it's square root of 0, which is a one time. We get one real solution. You can't do that part until you only have a squared left on both sides. And this we have a 10x and a 20, so that's not going to work. So then some of you might think, okay, well, then I'll subtract 20 because that's how we start by completing the square. And when I do that, I get a negative 20. So therefore, it means that there's no real solution. So there must be two non-real solutions. Again, you can't do that. We can't stop there because we're not going to square root it at that point. So you could complete the square and go all the way through and find out if once you do complete the square, if it ends up being a positive or negative. You can divide this by 2 like we normally do, b divided by 2. We get x plus 5 as our perfect square. Before we do that, technically we should have moved the 20 if that's the way that you do it. And you would get x squared plus 10x plus a square equals negative 20 plus a square. So now we know that 5 squared needs to go in this box and then goes in this box. And then this is where we could stop, because negative 20 plus 25 would give me a positive 5. So now I would get to where I can square root both sides, and I have a positive 5, which is telling me I'm going to have two real solutions. So you could do it that way. You could do it by completing the square, or you could do the quadratic formula. And remember, the quadratic formula, just this part here, is the part that if that's a negative number, we're going to have non-real solutions. If this is a positive number, then we're going to have real solutions. So you could also just do the square root part. And we know that a here is 1, b here is 10, and c here is 20. So we could just plug that in. B squared would be 100 minus 4 times a, which is 1. Ooh, I don't know what I wrote that. A is 1 times c, which is 20. And then we would do that math. 4 times 1 times 20 is 80. So this would be 100 minus 80, which is the square root of 20, which would be positive. And that's really all that we care about. As long as it's positive, then we know that we have two real solutions. If it equaled 0, that's when we would have one real solution. And if it equaled a negative, then we would have two non-real solutions. So remember, those are the three options you have. You have two real, one real, and that only happens when we have the square root of 0. And then two non-real. And that happens when our square root has equals a negative or has a negative underneath it. Both of them mean the same thing. That both of them are not possible for real solutions. So those are the three options. So, and that's how you would find it. Either start completing the square and see what the size equals. If it's positive, two real. If it's 0, one real. If it's negative, two non-real. Or just do the square root, which is what we call the discriminant, and just do that. And if it's positive, it means it's two real solutions. If it was a 0, that would be when we would get one real. And if it's a negative, that's when we would get two non-reals. Okay, let's move on to number 2. So this one's already set up with a square. We can't move the 3 because the 3 is inside with the square. So I need to get rid of the square. And hopefully by now, you know the square root and the square are inverse operations of each other. So the square and the square root, poof, go away. And x plus 3 is the only thing left on the left side. And the square root of negative 49 is the positive and negative, because remember, whenever you write square root, you need to include the positive and negative answer. And then negative 49 is 7i. So we're still not solved for x, so we need to get x by itself. So I need to subtract 3. So I subtracted 3. Now 3 is real and 7 is imaginary, so I can't put it together. And I should always put the real part first. So negative 3 plus or minus 7i would be our final answer for this one. All right, number 3. What would the graph of quadratic look like if it had one real solution? So we have a graph here. We know it's a quadratic, so that means it needs to be a parabola. And most of the time it equals 0. So we're going to think about it equaling 0. So we're going to think about it at the x-axis. So if it has one real solution, that means it's only going to cross the x-axis once, right at the vertex. So it'd be right here. If it has two solutions, then on the graph, our parabola is going to cross the x-axis twice. So we're going to make sure our parabola, and it doesn't matter where it crosses, it just needs to cross twice. It could be a positive, negative, it could be two positives, two negatives, it doesn't matter. It just needs to cross that x-axis twice. And then if it's two imaginary solutions, we're again thinking about it crossing the x-axis, and it wouldn't cross the x-axis. So the parabola needs to be completely, entirely either above or below the x-axis, never crossing it. All right, so these would be our three different ways to do it. One real, two real, and two imaginary. And again, that kind of goes along with problem number 1 that we just did. All right, number 4, it says by completing the square. So you have to do it by completing the square. Even if you really like quadratic formula, you have to do it by completing the square. Remember, the first step for completing the square is that we want to get the right C value in here. And in order to do that, we need to subtract 10. Now, some of you do it a different way, and that's fine, and you will get the same answer. But I'm only going to do it this way. So if you do it a different way, just make sure you get the same answer as me. All right, so I moved the 10 over so I can get the right C value. The way I find my right C value is I divide my B value by 2. And -6 divided by 2 is -3. So -6. So if this is negative, then that means this is negative. If it's positive, that means that they're positive. So pay very careful attention to that. So now I need to figure out what goes in my squared. And all I have to do is follow the end of this. What is 3 squared equal, and put it here. So 3 squared, just kind of go up the problem, 3 squared equals 9. So that's what's going to go in here, 9. And if I do it to one side, I got to do it to the other side. So now I combine these, -10 plus 9 is -1. So right now it should be dinging in my head. I'm going to have a non-real solution. So I take the square root of both sides, just like we talked about in problem number 2. The square and square root cancel each other out, and poof, they go away. I get x minus 3 equals the square root of -1. We wrote the square root in, so that means I write a positive and negative. And now the square root of -1 is just I. I still don't have x by itself, so I add 3 to both sides. So my final answer for here is x equals, I write the real part first, so the 3 goes first, plus or minus I. All right, so let's try part B. So same thing, I want to get the right C value, and I have a 30 my way, so I'm going to get rid of that 30 so I can find the right C value to complete the square. I'm going to rewrite that, write my square, because that's what I'm trying to do, is complete that square. I'm going to write -30 plus my other square over here. I'm going to find what goes in that square by dividing B by 2. I'm going to be very careful to make sure that this is a positive 10 divided by 2, so I'm going to write a positive 5 here. To figure out what goes inside my square, I follow the problem straight up. 5 squared is 25, so that means I'm going to put 25 in this and a 25 in this. I'm going to combine like terms over here and get a -5. Again, my antenna should be going up. A squared equals a negative, so I'm going to have 2 non-real solutions. I take the square root because I want to get rid of that squared. The square and square root, poof, make each other disappear. X plus 5 equals, we added the square root, so I'm going to add a positive and negative square root. Now, the square root of -5 is not a perfect square. There's nobody's, I can't take a perfect square out of it. It's just 5, but I can take an I out of it and make it a positive 5. Still not done because I need the X by itself. So I need to subtract 5 from both sides. And so my final answer for this one is going to be X minus -5, because I need the real term first, and then plus or minus I square root of 5. Final answer. All right, last section, number 5, is quadratic formula. Remember, We will give it to you on your quiz, but the SAT and PSAT will not give it to you, but they do expect you to use it to solve problems. So you need to have it memorized. Over to A. So it's right here, and it was at the top of the paper too, if you forgot. It's all the way at the top of your paper. I'm just writing it down here so we can remember. We always want to make sure they equal 0, which these are both set up nicely to equal 0. So then I can go ahead and find my A, my B, and my C. My A equals 4, my B equals -3, and my C equals 7. So now I'm just plugging it in. So I get -3. Well, first, the problem starts with a negative. So negative. Now I'm plugging in -3. Then the formula says plus or minus the square root. Now I just do b squared right away. So -3 squared is a positive 9. Do that in your head. Do not do that in a calculator. Otherwise, you're going to kill a puppy. And if you're from my class, you know what I'm talking about. So I plug that in, and then the formula itself says -4. Now my A, which happened to also be 4, and my C, which is 7. The easiest way to do this is to just put everything that's under the square root in the calculator, like this whole thing in the calculator, if you have a calculator. So we're going to do 4 times 4 times 7, and then we're going to do 9 minus that answer. Oh, let me do the bottom. Hold on. Sorry, forgot about the denominator. All over 2 times 4. All right, so now we're going to do the square root. And when we do all that math, we get the square root of -103. All right, so then the rest of the formula, we still have this plus minus. So -3 makes it a +3. So this is now a +3 plus or minus that 2 times 4 is 8. Now I have the square root of -103. I need to find buddies because 103 is not a perfect square. So I need to try 2. 2 doesn't work. I need to try 3. 3 doesn't work. I need to try 4. 4 doesn't work. 5 doesn't work. And if you keep trying all of them, none of them work because 103 is actually a prime number. So then we're good here. We can't break anything out except the negative. We can write it on the outside as an I. And then we want to separate the real and the imaginary parts. So I'm going to do 3 divided by 8 plus or minus I square root of 103 divided by 8. Now, if anything could be reduced here, I would need to reduce it. But 3 divided by 8 doesn't get reduced. And technically, there's a 1 here. And 1 divided by 8 is already reduced. So this is actually my final answer. There's no simplifying needed in the fractional part. But always check. All right, part B. So again, it's already set up equal to 0. So I can go ahead and find my A values. So my A is 5. My B is -14. And my C, oops, got the 10. My C is -3. Go ahead and plug it in. So negative B, so that's negative of -14, which will make a +14, plus or minus the square root. 14 squared is 196. 196 minus 4 times my A, which is 5, times my C, which is -3, all over 2 times my A, which is 5. This becomes a +14 because the negative makes it positive. This is 196. And then when you do all the math, you get 256. So the square root of 256 divided by 10, the square root of 256 is 16. So this really works out to be 14 plus or minus 16 divided by 10. So we can do that because this is a real solution. There's not imaginary. So we can actually do the math. So I need to do 14 plus 16 and then divide the answer by 10. And then I need to do 14 minus 16 and then divide the answer by 10. 14 plus 16 is 30. Oops, it didn't change colors on me. Oh, it's 30. Oh, they're going to change colors. There we go. 30 divided by 10. We simplify that. 30 divided by 10 is just 3. So that's one of my answers. 14 minus 16 is -2. I'm still dividing by 10. I can simplify that down to -1/5. There's my other answer. So these are 2 real solutions where this is 2 non-real solutions. All right, that's it.